In this video lesson, we're going to cover phase diagrams. Phase diagrams is simply a graphical representation of state of matter. When you think about what can affect the state of matter of a substance, most of us can think of temperature as being one of those effects. For example, if you increase the temperature, the state of matter will change from solid to liquid to gas. But pressure also affects the state of matter as well. A phase diagram shows what state of matter a substance will be in under certain conditions of pressure and temperature. It's important to note that while there are some general themes that we'll see, every substance has its own specific phase diagram that corresponds to specific temperatures and pressures. Let's go ahead and take a look at a sample phase diagram. That sample phase diagram can be seen to the right. Notice that pressure is on the y-axis and temperature is on the x-axis. When you graph this, you'll get three general regions. You'll get the solid region, the liquid region, and then the gas region. When you cross over from one region to another, this is where phase changes occur. For example, when you go from solid to liquid, that's where melting happens, and freezing will go in the opposite direction. Same for vaporization and condensation at the liquid-gas border. And this is also where you get your sublimation and your deposition, where you go directly from solid to gas or gas to solid. These phase changes will vary depending on the conditions of temperature and pressure. For example, as temperature increases, you'll notice that the boundary lines increase as well. Now there's some other points to notice here when you're looking at a phase diagram. First of all, right here in the middle, notice at this spot right here, the phases of solid, liquid, and gas all meet together. This point is known as the triple point. The triple point is a point or condition of temperature and pressure in which all three states of matter coexist at the exact same time. You can imagine this is a very unstable point to be at. The states of matter are constantly in flux at this point, and therefore this is not a very stable condition of temperature and pressure. Another point to be familiar with is what's called the critical point. Notice leading up to this point there is a very solid line between liquid and gas, but once you reach the critical point, the line disappears. This is the point where the distinction between liquid and a gas becomes undistinguishable. You can't tell whether or not the substance is a gas or a liquid. Notice this critical point happens at very high temperatures as well as very high pressures. Once again, a very unstable condition. Alright, let's take a look at some examples. First of all, it's important to note that no matter what kind of phase diagram you may be looking at, there are general themes. For example, shown on the screen are phase diagrams for carbon dioxide and for water. Though they may look different, they have the same general themes. For example, which state of matter tends to exist under high temperatures and high pressures? If you take a look at the phase diagrams, regardless of whether you're looking at water or carbon dioxide, high temperatures, which are over here, and high pressures, which are up here, notice in both tend to have us landing in the liquid region. What about high temperatures and low pressures? Well, high temperatures, but fairly low pressures, has us landing in the gas or vapor stage. And then finally, by process of elimination, low temperatures but high pressures have us landing in the solid region. Alright, let's take a look at the carbon phase diagram. When carbon is at a low temperature but a high pressure, what form is it in? If we take a look at the graph, low temperature, so relatively right here, but high pressure has us landing right up here. That would be the diamond region. Notice carbon actually has two solid areas because carbon has allotropes of different forms. So it's not enough to just say carbon is a solid, you have to distinguish which form. What about the second question? What would happen if you had carbon at a pressure of 10 to the third and you raised the temperature from 2000 to 4000? Well, 10 to the third pressure is right around here, and you're starting at 2000, which is right here. So let's make a point there. So this is your starting point. And then you raise the temperature to 4000, keeping the same pressure. you'll notice that we're moving from here to here. And so you'll notice that you're going from graphite to liquid. Graphite is just a form of solid, and so you're going from solid to liquid, which basically is it would melt. Let's look at another example. This time we're looking at carbon dioxide. What would happen to a substance if its pressure was approximately 2 atmospheres and its temperature increased from -78 to 31? So let's go ahead and write in our starting point. 1 atmosphere is about here, so 2 atmospheres is probably going to be about right there. And its initial temperature is -78. So our initial starting point is right there. Now we're going to increase the temperature to 31, which 31 is over here. So if we look at what happens, we actually do two things. We cross the solid-liquid barrier, and we cross the liquid-gas barrier. So the answer to that question is, it would go from solid to liquid, meaning it would melt, and that's going to happen right here at this temperature, whichever that is. And then it will go from liquid to gas, or it'll vaporize, and it would happen at this temperature right here. What would happen to a substance if its temperature was -78 degrees Celsius and its pressure changed from 2 atmospheres to 5 atmospheres? This time the temperature is remaining the same at -78, but our original pressure is about 2 atmospheres, which is about right here. And now we're dropping it to 0.5, which is going to be roughly about right here. And so now we see the changes happening vertically. We can see it's going through a phase change, but that phase change is happening right here along the solid gas region. And so the answer is it would actually go from solid to gas, which would be sublimation. Last practice, what state of matter is water in at 50 degrees Celsius and what atmosphere? If we take a look at those conditions, 50 degrees Celsius is somewhere right here in the middle between 0 and 100, and if we go up to 1 atmosphere, it's going to be right there in the liquid phase. What is the critical temperature and critical pressure for water? Well, if we take a look at the critical point, which is going to be right up here at point B, the critical temperature is 373.99, and the critical pressure is 217.75.